Unit 10 is all about the vertical stress below the center of a rectangular loaded area, or this is case 2. Unit 9, it's also a rectangular loaded area, but the point of consideration is at the corner, and Unit 10 is at the center. So this will be the difference of Unit 9 and Unit 10. Unit 9, we can say that that is case 1. Unit 10 is case 2, which yes, the point of consideration is at the center of the rectangular loaded area. From the figure, we have here your rectangular loaded area, and the point A is below the center of this rectangular loaded area. It is specific, it is definite that the point of consideration is at the center of this rectangular loaded area. If the point of consideration is not the center of the rectangular loaded area, we will be using the principle in Unit 9. The B is the shorter dimension, the L is the longer dimension. The vertical stress increase now at this point, at point A, is Q multiplied by I's of 4, where I's of 4 can be solved by the following equation. And notice that we have only two parameters, that is m's of 1 and n's of 1. So m's of 1 is L divided by B, and n's of 1 is equal to twice the Z divided by B. Take note also that the term in the arc sign must be converted to radians. So this term should be in radians. And again, to convert it into radians, that is simply multiplied by pi divided by 100. Also, the value of I's of 4 can also be obtained using table 3.10. We will be following the same procedure that we had in the previous lesson. So first, we have to determine the value of m and n. And then we refer to table 3.10 to identify the value of I's of 4. And then after identifying I's of 4, we simply substitute it to this equation. Q is given, we substitute the value of I's of 4 for us to be able to get the vertical stress increase at a point that is below the center of rectangular load. Let's consider a sample problem. Refer to figure 3.69. A flexible rectangular area is subjected to a uniformly distributed load. Still, Q is 225. Determine the increase in the vertical stress at a center at a depth of Z is equal to 3 meters. So in the figure, you do not see the point, but it is automatic that what we are considering is at the center of this rectangular loaded area. Same procedure as that of our previous lesson. Let us identify m's of 1. Given that L is 6 meters and B is 3 meters, 6 divided by 3 is 2 meters. And for n, that is twice the depth divided by b. So the depth is 3 meters and b is 3 meters. So 2 times 3 divided by 3, this is 2 meters. Since we already know the value of m1 and n1, we can now proceed to solve for the value of I's of 4, which is either using the equation or using the table. So let us first consider method 1. I's of 4 is 2 divided by pi times 0.433, 0.322. This has already been converted into radians. I's of 4 is 0.481. Substituting to this equation to get the value of the vertical stress increase, Q is given to be 225. So the vertical stress increase at the center is 225 kPa multiplied by the value of I's of 4. This is 108.225 kilopascal. Let us consider method 2 and see if we will arrive at the same answer. Again, m's of 1 is 2 and n's of 1 is 2 also. Be sure again to check the table that you are using, variation of I's of 4 with m's 1 and n's of 1. So m1 is 2. N1 is 2 also. This somewhere here. Therefore, this now becomes our value of I's of 4, which is the same value na lumabas sa equation na ginamit natin kanina. So, therefore, we will be arriving at the same exact answer, 108.225 kilopascal. So, the most important concept on this particular lesson is that the point of consideration is always at the center of the rectangular load. If the point of consideration is not at the center of the rectangular load, we use case 1, the principle that was discussed in Unit 9.